Hello guys, we are trying to find out which is more dangerous or which kills faster between the form of electricity gotten from a wall socket and the one we get from a battery. Okay, so on my screen is describing the type we get from a wall socket, so making reference to a 220 volts supply. Let's say this is what our socket is generating. So this graph we are seeing here, you can see a red movement going up and down, up and down. It is the oscilloscopic view of what is happening, in this setup of a socket and the load. All right, so if we watch, this red line goes up to 220, which is our peak value. Then it starts coming down, it gets to a point zero, bear in mind zero, then it now flows to the other direction, gets to 220, then it starts coming up again and it hits zero. All right, then it starts going up again. It will get to 220 in the one direction, it comes down to zero, gets to 220 in the other direction. So I just want you to bear in mind that there is a point, there is a degree, all right, or there is a time, let's use time, when an AC signal gets to a 0 volt value. All right, now let me quickly explain this concept of getting to 220 in one direction, coming down to zero and getting to 220 in the other direction. Take a look at the second picture below. Is a socket or any AC source with two terminals, right? How electricity works here is that at one cycle, whether up or down, let's use up for example, current will flow from this line A to the load and it will return back to the source through line B. Then at the other half cycle, which is, let's say, the one going downwards, current will flow from point B to the load and return back to the source through point A. So this process will keep on repeating, but at a very fast rate, going from A to load and coming back through B, going from B to the load and coming back through A. It is happening so fast. This change of polarity happens 50 times in a second. Now, referring back to our graph, you're going to see where I labeled 1, 2, 3. So it's explaining the number of complete up and down, up and down, up and down. That complete cycle is known as frequency. All right, so normally we make use of the 50 hertz frequency, like in my country, Nigeria. What this means is that it's going to change polarity 50 times in 1 second. Okay, now, in a layman's understanding, what this means is that anyone being electrocuted by such kind of electricity, you're going to be held and released 50 times in 1 second. So for 50 hertz frequency, okay? So it's going to vibrate your entire system 50 times in 1 second, all right? So calculate how many times it's going to vibrate you if you spend up to a minute there, all right? So, but what I want us to bear in mind is that there are times when this value gets to zero before it starts to climb to the peak again. There are intervals, no matter how small, when it gets to zero. All right, so we've done justice to the AC kind of electricity. Let's go to DC and see what happens in DC kind of electricity like we see in batteries. Let's see in the next video. Thanks for watching. Hello guys, we are trying to find out which is more deadly between AC electricity and DC electricity. In our previous video, we've taken care of AC, we've analyzed it very well. Now it's time to look into the DC electricity, which is a type of electricity we get from batteries and solar panels. Okay, so in AC electricity, in the video we did for AC electricity, we made use of 220 volts. We are also going to assume the same value. All right, now we have our graph which gives us the oscilloscopic view of what happens in a DC setup. Okay, now if you observe this graph, you're going to find out that the red line, which indicates the voltage level, is continuous. There is no point where it comes down to meet the 0 volt position. All right, so what this means is that at every point in time, unless the power shuts down or the battery goes down or the rectifier is being shut down, if you are being electrocuted by this value of DC voltage, a substantial value of DC voltage, it will keep you electrocuted at peak value there will be no point of coming to 0 volts position, unlike what you have in the AC that can rapidly bring you to 0 volts at some point. You can go back and watch the video we made on AC electricity to understand how it works in AC circuit. Okay, so looking at the picture below this graph, it shows us how current flows in a DC circuit. It maintains this order, flowing from this line A, point A of the battery, to the load, then it returns back to the battery through the line B. It maintains this order until this battery goes down, or if it's a rectifier, until it's switched off. Alright, so it maintains this order. The important point to deduce from these videos is that AC electrocution vibrates its victim so fast depending on the frequency. For example, a frequency of 50 Hz will vibrate its victim 3,000 times in a minute. And during this vibration, a victim can be lucky to fall out. You know what vibration means? Hold and release, hold and release. So during one of the release, a victim may be lucky to fall out of the contact. But when you are electrocuted by a DC source, there is nothing like falling out of vibration. It uses up the electrolyte, the fluid and the blood of the victim instantly, and the victim dries up at the shortest possible time. So guys, what's your take on this? Do you agree with me? Let me see your reaction and your opinions in the comment section. And once again, please be mindful of electricity. Electricity kills. Stay safe and thanks for watching.